Hello everyone, welcome to this next question on complex analysis. This question is from December 2014 consisting of 3 marks. It says if we are given this power series n going from 0 to infinity a n z raised to power n, this is the convergent power series such that limit n goes to infinity a n plus 1 divided by a n, that is equivalent to r. This is given to us, and moreover this p is given to be a polynomial of degree d. This is given. Then they are asking the radius of convergence of the power series, this one. What is this out of these 4 options, right? So for doing this, for solving this question, let us have a look at this result. The result says that for any power series of this form, the radius of convergence is given either using the root test or using the ratio test by these 2 formulas. So here in this question, we shall be using this formula in order to solve this, right? So here what we are given, we are given p is the polynomial of degree d. So that means let us assume px to be some polynomial, not px. Let us assume this to be pz, where z is any complex number. So this to be z raised to power d, the simplest of all, which is of degree d, right? So now our series would then be summation n varying from 0 to infinity p of n, that means nd a n z n. So in the new power series, this is our a n dash. Let us call for the new power series this to be a n dash. So now in order to calculate the radius of convergence of this newly created series, so it would be 1 by r dash. So I am calling the radius of this new power series by r dash. So 1 by r dash would be calculated using this limit n goes to infinity a n plus 1 dash divided by a n dash for the new terms. So we'll be having limit n goes to infinity. Let us substitute the values over here. So it would be n plus 1 raised to power d, right? For the into a n plus 1, and for the term a n dash we would simply have n raised to power d a n. So this is the term, and let us solve this. So we'll be having limit n goes to infinity. Here from this term we can take n to the power d common. So we'll be left with 1 plus 1 by n into raised to power d, right? This term multiplied by limit n goes to infinity and this a n plus 1 divided by a n. So obviously here this is given to be r. So we'll be left with 1 by r dash, that is equivalent to limit n goes to infinity. And when you substitute limit in this first expression, so you'll have this term equivalent to 0, right? So you'll be left with 1 raised to power d. So that would ultimately be 1, right? So we'll be left with 1 and multiplied by this r. So the new radius of convergence would be 1 by r according to this formula. But in the options we are given the radius of convergence for this new power series as r, d, rd or r plus d. So out of these, according to me, none of these is the option, because the correct option is that it is 1 by r and not r. So but in the CSIR net answer keys, they have given this option A as the correct option, but according to me, the radius of convergence for this newly created power series, that would be 1 by r. So I have an ambiguity of answer in this question, but accordingly this is the radius of convergence for the given series. If you have any comments for this question or any suggestions, you can write in the comments. Well, that is it for this video. Thank you for watching.